In exercise 7.3, we take a look at factorising three-term expressions. Now, before we begin, it's really important to understand that we need to factorise to find x-intercepts, so we can use the null factor law when we're sketching parabolas and, in future exercises. In geometry too, it also lets us find the dimensions of shapes. And then lastly, this is the inverse process of expanding brackets. So without further ado, let's take a look at example one. So these are your basic three-term expressions. The reason why it's basic is because when we factorize, we actually need to know the factors, right, of the constant when we're in the ax squared plus bx plus c generic parabolic, expression term. So here we have x squared plus 5x plus 6, which is, in the ax squared plus bx plus c formula, which is very generic for parabolas. The first step to factorizing these sort of simple basic three-term expressions is you need to look at the constant. So we circle the constant. Okay, let's undo that. What we want to do is we actually want to circle the plus minus symbol in front as well. We have to think to ourselves, okay, what are the factors of 6 which add up to 5 or positive 5? Right, so the factors of 6, and you want to make sure it's in, the multiplication combinations. For example, 1 times 6 gets you 6, or you could have 2 times 3, which gets you 6. Now, we know 1 times 6, if we were to add them together, positive 1 plus 6 gets us 7, so it doesn't equal the positive 5 that we need. 2 plus 3, however, does equal 5, okay? Because 2 plus 3, basic elementary addition, we know adds up to 5. So what we need to do here is we need to therefore write 2 brackets, okay, next to each other like we were in double bracket expansion. We know we need x's in both brackets because the first line over, x times x, gets us the x squared. After that, we need a positive 2 and a positive 3 because both are positives. It doesn't matter in which order they're in. Okay, it could be positive 3 in the first bracket or positive 3 in the second. Doesn't matter. All right. The reason why we chose positive 2 and positive 3 is because 2 and 3 they add up to 5, which is the b value, or the value right next to the x to the power of 1. Right. Let's see if we understood what we did in example 1a and example 1b. So remember, the first step is we always look at the constant. So here we've got a constant of 24. Now, what are the factor pairs of 24, which add up to positive 10? Is it 1 and 24? No, that gets us 25. Okay, so we can put little crosses. So 1 plus 24 gets us 25. Is it 2 and 12? Well, 2 and 12 adds up to 14, so that's not it either. Is it 3 and 8? 3 times 8 gets us 24. Nope, because 3 plus 8 gets us 11. So is it 4 and 6? Yes, 4 and 6, this equals 10, which is the b value attached to the x to the power of 1. So therefore, what we do is, because it's both positives, once again, we have 2 brackets drawn up. It doesn't matter which number's in which because they're both positives. So here we actually have a positive 4 and a positive 6, and that's our factorized expression of x squared plus 10x plus 24. Okay, nice and easy when we're dealing with these basic three terms expressions. You just need to know your factor pairs for the constant, which add up to the second terms, or the x to the power of 1's coefficient. Example 2, we take a look at non-monic three-term expressions. Non-monic meaning there's an x, or there's a coefficient in front of the x squared. So non-monic, let's highlight this. Non-monic, this means there's, oh, that's messy. Let's write in caps. Oops, that's not what we want. So there's a coefficient in front of x squared. So the reason being is this expression 6x squared, take away 11x, take away 10. The non-monic is the 6. Okay, so that 6x squared makes this expression non-monic. So what we need to do is, there's actually steps to this. Step 1. Okay. Multiply the x squared coefficient with the constant. It's always the x squared's coefficient with the constant. So what does that mean? We've got the x squared coefficient of 6 multiplied by the constant of -10. So therefore we have 6 times -10, which gets us an answer of -60. So, well, what does this mean? All it means is we need to multiply, or find the factors. So let's write the step first. Step 2. Okay, find the factors of -60, which adds to -11. Okay, so the factors of -60 needs to add up to the b value, or the coefficient in front of the x to the power of 1. All right, so the -11 came from here. Let's do some highlighting to make sure we know what we're talking about and where these values came from. Okay. -60. So the -60 was just from above, which adds up to -11. All right, so let's have a think of the factors of -60. So is it going to be 1 and -60? Well, that's not even close. Is it going to be anything like, could be plus minus, remember guys? 2 and a 30. Nope, we're still too far apart to get anything remotely close to 11. Is it 3 and 20? Nope. Even if it was plus minus either of them, we're still too far apart. Is it plus minus 4 and potentially 15? Yeah, it is. 4 and 15, we can get negative 11. How well, if we have negative 11, this means we must be further in the negatives than the positives. So we must have a negative 15 and then a positive 4, because positive 4 take away 15 gets us negative 11. So tick, since this equals negative 11. All right, so now that we've found our, let's put this on one page. So now that we've found our two terms, there's actually a step in between. What we need to do is we actually need to turn it into a four-term expression now. So step 3. Let's zoom in so I don't overwrite. Using, split the bx term into 2 with the answers above. So what does that mean? Let's write our original equation. So we had 6x squared take away 11x, take 10. So therefore, we actually have to split the negative 11x into these two proportions. So we would have a positive 4x and a negative 15x. What was the last term again? Let's take a look. Negative 10. So notice how the negative 11x has now been split into positive 4x, take 15x. Let's just keep this color code and keep going. So this part here was because of this part here, and this links back to the negative 11. Okay, back in the original equation. So from here, what we need to do is we need to factorize by grouping. So step 4. Factorize by grouping. What that means is we factorize the highest common factor out of the first two terms. So therefore we would have, if we were to take a look at 6x squared plus 4x and then negative 15x take 10, the first pair that's grouped together is 6x squared plus 4x. We can see there's actually a common factor and it's x. In fact, we can also take out a 2, since 6 and 4, the highest common factor of 6 and 4 is 2. And there's a common x between the two. And we always take out the lower power. So this means 2x times what gets us 6x? Well, or along the other way around is 6x squared divided by 2x would get us 3x. So we would have 3x because 2x times 3x gets us 6x squared. And then we would have 4x divided by 2x, which would get us 2. So that's a first group done. The next group, so that just corresponds to the first group. The next group, we've got negative 15x and negative 10. We can factor out a negative, since that's common in negative 15 and negative 10. We also know the highest common factor of 15 and 10 is 5. So we can take out a 5. Otherwise, there's nothing else that's common. So negative 15x divided by negative 5, using our skills that we learnt from last year in single bracket factorization. We know this is going to equal 3x. Right, because negative 15x divided by negative 5 gets us a positive 3 and an x left over. And then a negative 10 divided by a negative 5 gets us a positive 2. And what you notice is we now have 2 identical brackets. And if you remember from last year, if we have 2 identical brackets and coefficients attached on the outside of both, we can actually group the 2 identical brackets together and combine it into 1. So we would have 3x plus 2. Okay, and then we take the contents of the outside of the brackets and make it a bracket of itself. We would have 2x take away 5. Which one comes first and second? It doesn't matter, all right, as long as we have 3x plus 2 and 2x take away 5 in each bracket, we have done this correctly. All right, so non-mnemonics are a little bit harder. You need to make sure you've practiced quite a few of these by following these steps above, and hopefully that'll be okay for the questions. Let me know if you do have any questions about exercise 7.3.